All right, in this lesson, I'll show you how to create a bar chart or a bar graph with Matplotlib. And bar charts are really optimal for situations where you want to show things like counts, especially of entities that are independent of each other. So a really effective thing to call a plot method on and create a bar chart on is something like a series, especially something coming from, let's say, our value counts method, because we're going to have a perfect representation of how many times something occurs. So let's go ahead and show you an example of how we can create a bar chart. And I'll begin by actually writing a fresh data reader query. So let's do data.datareader. And I actually want to get information for Google. The information here is a little bit more varied than BlackBerry. So I'm just going to repeat the code to pull information from Google. Google went public sometime in 2004, so I'm just going to put my start date at January 1st, 2004. And I'm just going to end it at the end of the current year, which is 2016. And I'm going to store this in a variable called Google and just preview the first 3 rows. So by itself, this is just going to give us a data frame with numbers. And really what I want to do is do some kind of counts, and finding a count of identical stock prices is still going to give us hundreds of possible values, because how many days do we have where the stock price is exactly the same in a specific column. So let's create a situation that's much more ideal for plotting. Let's say I want to rank the performance of these stocks based on my own arbitrary calculation. Let's say if the stock price is less than or equal to 200, I want to call that a poor performance. If it's between 200 and 500, I want to call it a satisfactory performance, and anything greater than that will be a stellar performance. So in order to apply that kind of algorithm or ranking to my stocks, I have to write a custom function and then use the apply method to use it. So let's write that method right now, or rather that Python function. So I'm going to call it rank performance. It's going to take a stock price, and later it's going to iterate over every single value within one of my series here. So let's say if the stock price that's passed as the argument is less than or equal to 200, I want to return that it's a poor performance. Else, if the stock price is greater than 200 and less than, let's say, 500, I want to classify that as a satisfactory performance. And otherwise, which is basically going to mean everything greater than 500, we're going to classify that as a stellar performance. So I'm going to press Shift-Enter to load this Python function into memory. And now let's say we want to apply this function to something like the closed column. That's the stock's price at the end of the day at closing time. So I'm going to begin by extracting that series. There it is. So we have our date time index as well as the values. And now let's go ahead and call that rank performance function on every single value. As a reminder, we can do that with the apply method that accepts an argument of a Python function, and it applies that entire Python function to every value. So if I pass in rank performance, it's going to take 50.12, pass it to this function, get the result, which is going to be one of these 3, and then repeat the exact same operation for every other value. So when I execute this, we're going to get a series of strings now instead of numbers. So now we have something that's a little bit more consistent in terms of having identical values across the board. So now I can do something like call the value counts method. And this is the exact kind of perfect series here that's optimal for something like a bar graph, because it really is supposed to showcase independent entities. So something like a line graph, which we discussed previously, is meant to show trends over time. So we showed, for example, BlackBerry's price from a month to another month to another month, and there's kind of connectivity between there. Here, the stock performances aren't really connected. We really just want to have a count of how many times it performed in this category versus this category versus this category. So a series like this is perfect. And when we call the plot method, of course, by default, it's going to create the standard which we saw in the last lesson, which is a line graph. So when I execute this, I'm going to get a line graph, and you can see there really is no relationship between these 3 points. They're all separate. So a line graph isn't the best thing to plot here. By the way, the default parameter argument that's affecting this is a parameter called kind. It's not visible here because I'm method chaining so severely, but the plot method has a kind parameter, and its default argument is line. So that's why it's rendering as a line graph by default. The other thing I want to bring up here is the reason it's rendering like this with this visual format is because I still have my style activated from the last lesson. So if you're seeing a different result visually, you can just put in a code here that is plt.style.use, and I'm using the style ggplot. So that should give you the exact same looking graph as far as visuals and colors and fonts. But back to what we were talking about, we have this parameter called kind, and its default argument is line. And predictably, if you want to change it to a bar graph, which is a better representation of this data, we can just change it to bar, and it's going to give us a bar graph, and immediately we can see that the x-axis has still retained its values, satisfactory, stellar, and poor, and the y-axis has still retained its numeric values, which are the counts that we were seeing in that value counts result. But now the entities are separated. They're not linked by a line, which doesn't mean anything in this case. It's just the count. And so it's a much better representation, and we can see that satisfactory is the dominant performance category here. Of course, keep in mind that this is our own totally arbitrary definition and should not be construed as any kind of financial advice. The alternative here to this vertical bar graph is, of course, a horizontal bar graph, which I think is even more better because we can see these values written out horizontally and read them a lot more easily. So the argument that we can feed here instead of bar is bar h. That h simply stands for horizontal. That basically swaps the axes, and here you can see we're going to get this new horizontal bar graph. We have our values from the index of our series, our value count series, represented here on the left, and here we have the numeric values here on the x-axis. We can immediately see that satisfactory takes the lead, and then stellar and poor are roughly neck and neck when it comes to competing how many days have that classification. So that's a bar chart within Matplotlib.